Hey everybody, in this video we are going to be exploring an example of matrix multiplication. I did a couple of other quick examples of matrix multiplication in my other videos, so if you haven't watched that you need to check that out. But we're going to jump right into this example. So we are given the following. We're being asked to compute the product C times D, and we're given two matrices. We're given a matrix C, which is what we call a column matrix sometimes a column vector, which has 4 rows, 1, 2, 3, 4, and 1 column. And then we're given what we would call a row matrix, or sometimes called a row vector, that has 1 row and 3 columns, 1, 2, 3. Okay, so let's write solution here, and we need to go ahead and calculate this. So let's go ahead and write their sizes here. You know, C, again, it's a column matrix or column vector sometimes called. So that's a 4 by 1, 4 rows and 1 column. And then we're going to say times D, which is a 1 by 3 row vector. Okay, so the first thing we can notice is that the number of columns of the left matrix is equal to the number of rows in the right matrix. So this can be computed. All right, we're allowed to compute this. So we're going to say equals, and we're going to put these up against each other, with the left matrix being C, 1, 0, 3, 2, close that off. And then the right matrix is D, 1, 0, negative 3. Okay, and so what is the size of the product? Well, the product, we're going to say let's call the product maybe matrix E, and we're going to say matrix E should have what size? Well, it should be the number of rows of the left matrix and the number of columns of the right matrix. So this product should have a size of 4 by 3. Okay, so let's open this up. Let's open up a bracket and let's start populating these. So remember, what you need to do is you need to multiply each of the rows of the left matrix by each of the columns of the right matrix, and then add those products together. Okay, so in the 1, 1 entry, we're going to say row 1 of the left matrix by column 1 of the right matrix. So that's 1 times 1. Now that's it. There are no other entries in row 1 of C, and there are no other entries of row 1 of column 1 of D. Okay, so it's just 1 by 1. That's the 1, 1 entry of our product. Now let's move on. Let's find the 2, 1 entry. Row 1, the 1, 2 entry. Row 1, column 2. Okay, so row 1 by column 2. So we're gonna say 1 by 0. Okay, now let's go row 1, column 3 of the product. Row 1 by column 3 is this. All right, so that takes care of our first row of our product. Move on down. We're going to say the second row of the left matrix and then times the first column of the right matrix. So that's going to be 0 times 1. Next, we're going to do row 2, column 2. That's the 2, 2 entry, 0 by 0. Row 2, column 3. Okay, 0 by negative 3. That's it. Okay, moving on down. The third row by each of the columns in the second matrix. So row 3 by column 1, 3 by 1. Row 3 by column 2, that's 3 by 0. Row 3 by column 3, that's 3 by negative 3. Okay, and then last one, row 4 by column 1, so 2 by 1. Row 4 by column 2, oops, did not mean to scroll there. Row 4 by column 2 is 2 by 0. And then row 2 by column 3 is 2 by negative 3. And we can go ahead and multiply all this out. And let's see what we get. The first entry is 1. Row 1, column 2 is 0. Row 1, column 3 is negative 3. Move on down. We have 0, 0, 0. Move on down. 3, 0, negative 9. Move on down. 2, 0, negative 6. And there we go. That is our answer. That's our product right here. And notice what the size is. The size is a 4 by 3. Sure enough, that's what we needed to get. So again, I can't emphasize it enough. The way you actually perform this multiplication process when you're multiplying two matrices is you say the row entries of the left matrix multiplied by the column entries of the right matrix. And in this case, you didn't have to add anything together because you just had a single column here and a single row in your right matrix. So that's going to conclude this example. Thanks for watching.